Hi there, welcome back. We're going to look at section 3.6 today, which is on absolute maximum and the absolute minimums. So we've already learned how to use the derivative to find where functions are increasing and decreasing. And based on that, remember, we were able to find local extrema, where the local max and mins are, where we went from increasing to decreasing. So we found out that sometimes we have several local extremes, right? There could be more than one. But in functions, however, there's only going to be one largest y value and only one smallest based on an interval in that function. So if we give you boundaries, and let's say there's 2 or 3 maximums in there, one of them is going to be the maximum, the highest, the largest value. And on the other hand, if we give you a range between certain numbers and you have a couple of minimums, well, then one of those minimums will be the smallest value out of all of them. So we call those values absolute. They're the absolute max and the absolute min. And typically you're going to be given a boundary, okay, between these numbers. Find that value. Okay, so that's what we're getting ready to do today. Most of you don't have any problems with this unless you just make some careless mistakes along the way. But typically, this makes kind of pretty much sense as far as what we're doing. All right, so we're going to figure out max and mins today in real life applications, and we're going to look at finding the absolute max or the absolute mins. Okay, so definition, first one, if C is in the domain of F and for all the x's in the domain, we have that the y value at C is greater than any other of the y values in the function. That's what this is telling you. This is bigger. Then f of C is called the absolute maximum. And on the same token, if f of C, which is the y value at C, is the smallest value in the whole function group, then f of C is called the absolute min. Now keep in mind when you are asked to find the absolute value, the absolute max or the absolute minimum value, they're looking for the y values, okay? That's how high up and down on a graph you are. The max is up high, that's a y value. The min is down low, that's a y value. Sometimes they'll ask you where is the absolute max. If they ask you where it is, that's the x value. But today we are actually giving the absolute max and min. So we're going to be given the y values. Okay. Number 2 says if a function f is continuous on a closed interval, then f will have an absolute max point and an absolute minimum point. Okay. So if they give you an interval, you can always find the absolute max and you can always find an absolute min. And that's what we're getting ready to do today. Okay. All right, number 3 says, here's how we're going to go about doing this. So if you're asked to find an absolute extrema, so that means whether it's the maximum or minimum, okay, of any continuous function f on a closed interval, they're going to give you the 2 numbers. First thing you're going to do is find all the critical numbers, critical values for f in a and b. That's where the derivative equals 0, okay? That's what the critical values are. Remember, we're going to find where there's horizontal tangent lines, where the derivative equals 0. Those are your possible maximum and minimums. Then we're going to evaluate the y values of the endpoints. So whatever they give you, we're going to evaluate those. Right? And then we're going to evaluate whatever we get here for the x values. So that's pretty easy. We're just going to plug those numbers into the function. And then out of those y values, the largest will be our absolute max, and the smallest y value we found will be our absolute min. Okay, so we're going to start off by just looking at a graph so that you understand kind of this process. So here's a function, okay? It goes on in both directions, but we want to find just the absolute max and the absolute min of the function in the interval between -4 and 6. So we want to stop here. I don't want to look any farther than there to the left, and I don't want to look any farther than 6 to the right. So they gave me boundaries, because if they didn't give me boundaries, there is no max. This is going to go up and up forever, right? But because I have boundaries, there will be a max. So what this says to do up here, find all the critical values for f. So the critical values are where there's max and mins in your problem, where there's horizontal tangent lines. So here's one, and here's one. Okay? So these would be where the derivative equaled 0. Okay? The horizontal tangent lines. So I have to look at those y values and the endpoints. Okay, so we found the critical values, and now we're going to evaluate the y values of the endpoints and of those critical values. All right, so let's just look at the ordered pairs. Here's the endpoint. Can't go any farther than -4. So that looks, I don't know, that looks like -4. I don't know, like -1.75 almost, right? Here is at -3. That ordered pair is -3, let's say -2.5. This value is 2, let's just call it 2, 3 for the sake of what we're doing. I know it's a little bit below 3, but let's just call it 2, 3. Here is 4, 1. And then our endpoint was 6, 5. Okay, those are just the ordered pairs, the endpoints and the critical numbers. So what we're now, so we found the y values of each of them, the y values, okay? And so now it says the absolute max is the largest y value. The absolute min is the smallest y value. Well, the largest y value I have is right here. So we would say 5 is the absolute max. Okay. And then what is the smallest y value? That would be right here. So -2.5 is the absolute min. Okay. So those are the steps looking at the graph. Now we're going to do it obviously with the functions, but just so you can kind of see it. So if this didn't end here, this arrow kept going, then that would not be an absolute max. But they're saying we only want to look at this graph between these points. So you will always find an absolute max and min if you're given endpoints. Okay? All right, so keep these 3 steps. This is what we're going to do. 3 steps. Find the critical values, find all those y values, and then pick out the largest and the smallest. Okay, so not too bad today. All right, so number 2. Now we're going to be given functions. Find the absolute max and the absolute min for each of these functions between this given interval. All right, so step 1 is to find the critical numbers. So that's the derivative. Find the derivative. Okay, the derivative of -5x is -5. That's it. We can't set that equal to 0, so there is no critical numbers here, okay? So there's no critical numbers. Okay, I can there's no x in this problem, so I can't set it equal to 0 and solve if there's no x. So that means I just have to find, step 2 is find the function values of the endpoints and the critical numbers. Well, there was no critical number, so I just need to find the function values, the y values at -3 and 9. Okay, so we're going to put -3 in here. So -5 times -3 plus 5. So that's +15 plus 5, which is 20. And then we're going to put 9 in here. -5 times 9 plus 5. That's -45 plus 5, which is -40. Okay? And then step 3 is to pick out the largest and smallest values. Well, we only got 2 numbers, so that's pretty easy. So our absolute max is 20, and our absolute min is -40. Okay? So those are the 3 steps looking at a function. All right, so let's try one that hopefully has a critical number. All right, so step 1 is to find the critical number. So that's the derivative, where the derivative equals 0. So find the derivative, be 18x plus 18. Okay. And we're going to set that equal to 0 and solve it. So set 18x plus 18 equal to 0. That's 18x, move the 18 over, become negative 18. So we end up with x equals negative 1. Now, make sure that this is in this interval. Sometimes they are and sometimes they aren't. They have to be in here to use them. So it is. So step 2 now is I'm going to find f of negative 3. I'm going to find f of 2. I've got to find the y values of the endpoint. And I'm also going to find f of negative 1. That's the critical number. So you have to find the y values of your endpoints and any critical numbers. All right, now we can plug all this in and get this, but I'm going to use my calculator because for this section especially, I like to use this, and this is a good time to show you guys. We did it earlier, but just in case you forgot. So we're going to put the function in because I want the y values of the function, not the derivative. So I'm going to put the function in, 9x squared plus 18x minus 4. Okay? And now do me a favor and go to table set with me. So do second window and make sure that your independent variable is on ask. Okay? Leave this one on auto, put this one on ask. You just go down to it with the arrow and hit ask and then hit enter. Make sure that the black box is around those two things. And you can arrow off to make sure. Okay, now we're going to go to the table, which is second graph. And if you have any numbers in there, just hit delete. Just hit delete, delete until everything goes away. All right, so now instead of having to work this out by hand like we did with this one, I'm just going to put these numbers in my calculator. So negative 3 to negative 1. So there are my y values. Okay, so I got 23, 68, negative 13. You can do it by hand, but I just like doing this because it just saves me some time. So I'm just getting those y values. All right, so step 3, put that over here. What is your absolute max? That's the largest of these, 68. And your absolute min, negative 13. Okay. Now remember, if I said at what value does the max occur, the max occurs when x is 2. But if I ask you what is the absolute max, then that's the y value. Okay, so be careful with how you're being asked or what you're being asked before you jump in on the answer. Okay. All right, let's look at part C. So 3 parts. We're going to find the derivative, set it equal to 0, see if there's any critical numbers. So the derivative of this will be negative 3x squared, and then that's 0. So there's your derivative. So we're going to set negative 3x squared equal to 0 and solve that. Well, that's pretty easy. We're going to divide by negative 3, we get 0. Take the square root of 0, we get 0. Is 0 within this interval? Yes, it is. So step 2 then will be to find f of negative 5, f of 7, the two endpoint y values, and f of 0. It's our critical number. Okay? So again, you can do this by hand. You can plug these in right here and get your answers. Or, as I like to do, go to y equal, clear out that old one, put in negative x cubed minus 6. Okay, make sure you put a negative sign here, not minus. And then you're going to do second table and hit delete, get rid of those old numbers. And we're going to enter these numbers, negative 5, 7, and 0. And there's our y values, 119, negative 349, and negative 6. Okay? All right. So, step 3, what is your absolute max, and what is your absolute min. Your absolute max is the biggest number, 119. Your absolute min is the smallest number, negative 349. Okay? So again, derivative, find the critical numbers, find the function values of the endpoint, find the function value of any critical number as long as it's in that interval, and then pick out your largest and your smallest numbers. Okay? All right. Getting a little bit tougher on these derivatives now, so let's look at part D. All right, so for part D, again, when I do the derivative, I don't want to do a quotient rule here, so I'm going to rewrite the function. So I'm not going to find the derivative yet. Let's just rewrite that. Negative 3x minus 507x to the negative 1. It's easier to take the derivative that way. Okay, here's my interval, 614. All right, so the derivative of negative 3x is negative 3. The derivative of negative 507x to the negative 1 is positive 507x to the negative 2. Right? Negative times negative is positive, and then subtract 1 from that. All right, so I'm going to rewrite that. Negative 3 plus 507 over x squared, and we're going to set that equal to 0. Okay, remember, when we work with it, we don't want to work with negative exponents. So rewrite the derivative so that it looks easier to work with a positive x squared there. All right, so I'm going to take this negative 3 and I'm going to move it over there. So 507 over x squared equals 3. I'm going to multiply the x squared over to this side to get it out of the bottom. So that would be 507 equals 3x squared. I'm going to divide both sides by 3. 507 divided by 3 is 169. And then I'm going to take the square root of 169. Well, the square root of 169 is a positive or a negative 13, right? Both of those work. So I got two critical numbers, positive 13, negative 13. But my interval is only 6 to 14. So negative 13 is not in that interval. So I'm only going to use x equals 13, okay? If my interval was from negative 20 to 14, then I would use both of those. But for this problem, I only care about the numbers between 6 and 14. So I'm only going to use 13. All right, so that was all step 1. Step 2 is to find the function values of the endpoints. So find f of 6, f of 14, and find the function value of any critical number. Okay? All right, so again, I'm going to plug this into my calculator. I could work it out. I know you guys would rather not. I'd rather not. There's no reason to. We got a calculator. So negative 3x minus 507 divided by x. Okay. I don't need parentheses around that because it's going to do the division first, so I should be fine. All right, we're going to go to the table, delete out the old numbers, and we're going to put in the new numbers, 6, 14, 13. All right, so we got negative 102.5. We got negative 78.21 and negative 78. All right, so we need the largest and the smallest. So the absolute max is the largest number. The largest number would be negative 78. The absolute min is the very smallest number, which would be negative 102.5. Okay? All right, getting the hang of it? All right, so let's try part E. Okay, these are some big numbers, so just take your time when you're working it out. All right, so we need the derivative. So f prime. So we've got 6x cubed. The derivative of that is 18x squared minus 99 times 2 is 198x. And then 540x, that derivative is 540. Okay? All right. So we're going to set that derivative equal to 0 and solve it. Okay, so we're going to set 18x squared minus 198x plus 540 equal to 0. And I'm pretty sure 18 goes into all of these. So we're going to divide everything by 18 to get this to be a little bit easier to work with. So if you divide 18 by 18, that goes away. 198 divided by 18 is 11x. 540 divided by 18 is 30. So that's much easier to work with. All right, so now we can find the critical numbers. We're going to factor that. It factors x minus 5, x minus 6, right? 5 and 6 give me 30, and negative 5 and negative 6 gives me negative 11. Set those equal to 0 and get your critical numbers. So we get x equals 5 and we get x equals 6. We get two critical numbers. Both are in this interval. So now I'm going to need 4 y values, okay? So for step 2, I still have to find the function values of the endpoints. And then I have to find the function values of the critical numbers that are in the interval. Okay, so I'm going back to y equals. Put in the function 6x cubed minus 99x squared plus 540x. Okay, so there's our function. I'm going to go to my table, delete out those old numbers, and I'm going to put in these 4. Negative 4, 8, 5, and 6. Okay, so there's my values. Negative 4128, 1056, 975, 972. Okay, so pick out the largest and the smallest. So for step 3, your absolute max is 1056, right? That's the largest number. And your absolute min, smallest number, negative 4128. Okay, and a lot of times it will be the endpoints, but every now and then there's one will jump up or down. So you do have to look at the critical numbers and figure those out. Okay, and if you're showing your work, like I said, I don't mind you doing this on your paper because I know you can use your calculator for that, but I do want to see the work for those problems. Okay, all right, last page. Getting into some applications now, so let's see what these are going to ask us. Okay, all right, so number 3 says the cost of producing X electronic games is given by this function, cost, right? 1080 plus 42x plus 0.3x squared dollars. Find the value of x that minimizes the average cost function. Okay, find the value of x that minimizes the average cost function. All right, well, remember the average cost function is that we have to plug in the endpoints and get the slope and find the equation of that line. Okay. Find the x value that minimizes the average cost function. Yes. So, okay. So our average cost function, we need to plug in our endpoints, 0 and 90. So let me stick that into y equals. For 2x plus 0.3x squared. Okay? All right, and let's get our y values. So we're going to put in 0 and we're going to put in 90. All right, so there's my y values. So I've got 0, 1080, and I got 90, 290. Okay. All right, so we're going to find the slope. So we've got 7290 minus 1080 over 90 minus 0. Okay, so 7290 minus 1080, 6,210 over 90. And I'm going to divide that by 90. So we get 69. Okay, so there's the slope of your function. And then we're going to use either one of these points. So y minus y1 equals m times x minus x1. So that is y minus 1080 equals 69 times x minus 0. So we get y minus 1080 equals 69x. So our function would be y equals 69x plus 1080. Okay. All right. So there's your function. And after all of that, we're going to come up with the fact that the derivative of this is just y prime, which is just 69. So there's no x value in here. So we don't have any other critical numbers that we can find. Remember, we're supposed to set this equal to 0. Well, 69 equals 0 is a false statement, so there is no critical number. Okay? So if there's no critical number, then we've already found our two function values here. And it wants to know the x value that minimizes this cost. Well, the x value would be 0, but remember, we're not including 0, so it's going to be right above 0. So since we're producing games, I'm going to assume that our x value will be 1. We can't have part of a game. And we're not going to be able to use 0. Okay? So this graph is just increasing all the time. So we're going to say that our x value that minimizes the value would be 1. Because again, we can't use 0. That's the minimum. I know this thing is going to keep going up. Okay? It's a slope, it's a line. So it's just a line doesn't change, goes up. So 0 is not a possible answer, but 1 is. We can plug 1 in there and figure that out too. If we want to put 1 into our function, into the table, okay, 1122.3. So that is the largest number, right? So at 1, we were at 1122.3. I mean, sorry, small. Okay, so can't use this one. So this would be the next smallest number. So 1 would be that x value that minimizes this cost function. All right, last one. The weekly revenue from the production and sale of X units of oil is given by 78x minus 3x squared. That's the revenue. It's in thousands of dollars. The cost function is given by C of x equals x squared plus 30x plus $7,000. Find the number of units of oil that are to produce to maximize the profit when x is between 0 and 27. All right, so remember the profit is your revenue minus the cost. So we need to find that function first, and then we can find the derivative of that function and then get our test points. Okay, we're trying to find the maximum. All right, so r of x is 78x minus 3x squared. That's the revenue, minus the cost, which is x squared plus 30x plus 7. Let's simplify that. So this is the profit. So we have 78x minus 3x squared. We're going to distribute that minus sign through here. So minus x squared minus 30x minus 7. Add your like terms. So let's put the x squared first. So minus 4x squared, those two. 78x minus 30x is a positive 48x minus 7. All right, so there's your profit function. So now we can find the derivative of that, set it equal to 0, find any critical numbers, and then find our values at the endpoint and our values of the critical numbers. So the derivative of the profit, negative 4 times 2, that's negative 8x, plus derivative of 48x is 48. We're going to take that and set it equal to 0. Solve. So I'm going to move the negative 8x over to the other side to make it positive. Divide both sides by 8. 48 divided by 8 is 6. So there's a critical number, which is between here. Okay, so I want to find the profit function at 0, at 27, and at 6. Okay, remember, we're trying to maximize the profit. Okay. So again, you want to put this in your calculator, however you want to do that, but we're going to plug it into here. So I'm going to put in negative 4x squared plus 48x minus 7. Okay, there's the profit function. I don't want to put the derivative in. Remember, I'm trying to find the profit. All right, so go to your table, plug in these values, 0, 27, 6. All right, so at 0, we got negative 7, at 27, negative 16, 27, and at 6, 137. Okay? All right. It asked us to find the number of units of oil that are to be produced to maximize the profit. So 6 is the number of units of oil that are going to be produced. The maximum profit is this, okay? But look at what it asked you to find. Find the number of units of oil that are to be produced to maximize the profit. So we would need 6 units of oil to produce the maximum profit. That's what it asked you for, okay? 6. What is the maximum profit? That would be $137,000, right? They didn't ask me for that though. They just said find the number of units. Okay. All right, so please be careful when you read these word problems that you're answering what it's asking you for. Okay, so that was a little tricky because I would say a lot of you would put 137. So just read the question carefully, okay? All right, so that does it for this section. So hopefully you've got enough to get your homework done. And if not, please reach out to me and let me know if you need any help. See you here next time.